All right, today we're going to jump in a bit of a time machine. We're digging into the archives to talk about an idea that, honestly, shaped the world we live in today. It's called the Perceptron. And no, this isn't some brand new thing. This is the original blueprint for artificial intelligence, and it was drawn up way, way back in 1957. So let's see how this whole thing got started. You know, the entire project, this whole massive undertaking, really started with one simple question. A question that sounds like it's straight out of a sci-fi movie, but it's so fundamental. Can you actually build a machine that doesn't just compute numbers, but learns to perceive the world? Can a machine learn how to see?
And here's the kicker. This question wasn't asked last year or 5 years ago. This document right here, from the Cornell Aeronautical Laboratory, is dated January 1957. I mean, think about that. Over 60 years ago, these pioneers were already getting their hands dirty with the very foundations of what we now call machine learning. It's just incredible.
So, what was the actual problem they were trying to crack? Let's break down the challenge they were up against in building a machine that could actually perceive something.
Okay, so here was the big hurdle. You and I, we can look at a coffee cup, and we know it's a coffee cup, whether it's right in front of us, far away, upside down, or in a weird shadow. Our brains just get it. That's a concept called stimulus generalization. But for a 1950s computer? Nope. To its rigid logic, every single one of those was a totally different alien object. They needed a completely new way of thinking.
And that new approach was wild. It was radical for the time. Instead of trying to write some perfect, complicated set of logical rules, the project's lead, a guy named Frank Rosenblatt, he just threw that idea out the window. He said, let's not model this machine on a calculator, let's model it on the human brain. The goal, and this is a direct quote, was to formulate a brain analog. And they gave this brain analog a name, the Perceptron. Now, here's the most important part to understand. This machine wasn't designed to be perfect. It was all about probability. It wouldn't know for certain that it was looking at a square, but it would learn, over time, to make a really, really good guess. It wasn't about rigid programming. It was about learning from experience. You know, just like a person does.
So how did this electronic brain actually work? I mean, what was under the hood? Well, let's take a look at the surprisingly elegant three-part system that made it all tick.
The whole design breaks down into three simple stages. First, you've got the sensory system, or S system. You can think of this as the eye. It just takes in the visual data. That data then gets passed to the association system, or A system. That's the brain, where all the heavy lifting and processing happens. And finally, you have the response system, or R system, which basically shouts out the answer. It's really just see, think, and act.
But the real magic, this secret sauce, is all in that middle part, the A system. This is the heart of the machine. It's not one single processor. Instead, it's this web of interconnected little electronic units, basically artificial neurons. This is where all the signals from the eye get chewed on, processed, and most importantly, where the machine starts to form memories.
Now, to get how it learns, you only need to know about two kinds of signals. When one of those artificial neurons gets a signal, it can be excitatory. Think of it as a +1, a vote for something. It strengthens a connection, making a certain answer more likely. Or it can be inhibitory, a -1, a vote against something. It weakens a connection, making an answer less likely. It's really just a big election happening inside the machine.
And this really simple system of positive and negative votes, this is what lets the machine do the most incredible thing of all, learn from its own mistakes.
So let's just walk through a quick example from the original paper. Picture this. Step 1, the perceptron is shown to square. Step 2, based on its totally random initial wiring, it makes a guess. It says circle. Wrong. So step 3, an operator steps in and gives it feedback, basically forcing the machine to output the correct response, square. And in that instant, here's what happens. The system automatically reinforces all the connections that should have led to the right answer, and it weakens the ones that led to the wrong one. You do that over and over and over, and eventually it learns.
So what even is a memory inside the perceptron? This part is so brilliant. It's not a file, it's not saved on a disk. A memory, like the idea of a square, is just the specific pattern of connections, the web of active neurons, marked here with X's, that have been strengthened over time through all that reinforcement. The memory is the network. The structure is the knowledge. It's wild. So you might be thinking, okay, cool lab experiment, but so what? Well, this wasn't just some forgotten project. This was the beginning of something that would, quite literally, change everything.
The sheer ambition they had is just staggering. I mean, listen to this. In their 1957 proposal, they weren't just thinking about telling squares from circles. They said, and I quote, they expected these devices to one day be capable of concept formation, language translation, collation of military intelligence. They weren't just building a pattern recognizer, they thought they were building a mind.
And here's the key takeaway. The perceptron's core ideas, that network of simple neurons, learning by strengthening and weakening connections, those are the direct ancestors of the deep neural networks that are all around us today. Seriously, think about the spam filter in your email. Every single time you mark an email as junk, you are acting like that 1957 operator. You're giving feedback that strengthens certain connections, teaching the network to get better. This wasn't just an experiment. It was the blueprint.
It is just incredible to think that this elegant, simple concept from 1957 is the great-grandparent of the AI that's sitting in your pocket, that's driving cars, that's composing music. It really makes you wonder, right? If all of this grew out of that original blueprint, what on earth will its descendants look like in another 60 years?